Cool. Okay, well, welcome everybody. Welcome to GlasgowJS as part of the Scottish Technology Club. Oh, someone's at the door. Thank you very much. Cool. So welcome to GlasgowJS. My name is Kelsey. I'm one of the, I guess you could call them the temporary hosts. We sort of rotate through the hosts depending on the event, and that is me today. I work for BJSS, which is this office that you're all sitting in. So I've got an orange lanyard on. I'm also like first aid trained and stuff. So if anybody needs me, come find me, or Lee, who's sitting way up in the corner over there. Feel free to grab one of us. So a couple of health and safety, first aid things that I'm just going to fly through. If there's a fire, calmly make your way down the stairs. Outside, there's a building, 168 West George Street. That's like the company meeting point, so it's probably where we should go as well. Access through the main reception door, downstairs, West George Street, right there. And then talk to me and Lee, we'll sort it out. There's also a rear fire door, accessed from the lockers near the toilets, which is behind you guys. First aid, if there's any first aid issues, there is a first aid box. Let Lee, again, over in the corner, or myself, know of any first aid issues. Bins, you've probably already seen them because you've been eating pizza, but we have some nice recycle bins. Try your best to use the right bin if you can. Just makes it easier for us at the end of the night. Smoking and vaping. Obviously, this is a no smoking, no vaping area, but it is important to note that outside, the doors lock. They've already locked now after 6:45, so you will need somebody to let you back in through the door. Same if you have to leave early. You'll go down, you'll go to exit, and they just won't let you out. But there's a little button at the side that you click, and it will just open up the doors. So if you get confused or anything, come find me, or talk to somebody about letting you back in if you have to go out for whatever reason. And lastly, the toilets are right behind you two there in that little corridor if you need them. Now, quick thank you to the lovely sponsors of the event, including BJSS, who have given us a space. They've given us a pizza, the drinks. They're my employers, so thank you. Cool. And lastly, we're going to the pub afterwards. We're probably going to go to Wetherspoons just because it can accommodate a bunch of people without pre-booking in advance. So it'll be, what's the name of it? The Society Room. It's the nearest Wetherspoons to here. And it's always a good time. I don't drink alcohol, so there's no prerequisite to be there drinking. It's just a nice time. Now, over to the speaker. If you've ever wondered how a game engine works, this is Samuel Davidson, and he is here to show some of the lessons he's learned building a few of his game engines. So without any further ado, welcome Samuel.
Hello, everybody. So thank you for coming to the talk. I'd like to say that the stuff that I'm going to show you, it's not I'm not an expert at building game engines. I've probably been doing it for about 2.5 years. And so the stuff I'll say is not this is how the industry does it. I happen to know quite a lot about how the industry does it, but I'm definitely not an expert. So it's my personal journey. So game engines from scratch. I thought I'd probably get into, first of all, why build a game engine from scratch? Because it's such an undertaking to get into that you have to have a pretty good motivation. So my personal why I started was because I wanted to gain experience. And if you want to get better at pretty much every aspect of programming, build a game engine. It is just unbelievable how difficult it is and what parts of computing science a game engine touches. I can't honestly think of a single part of computing science that some kind of game engine doesn't touch. So if you want to get better at programming or you want to learn programming, you can go from pretty much nothing all the way up to Unreal Engine 5. I mean, you probably can't, but that's the scale from very entry level all the way up to something very complicated. So if you want to gain XP, that's a great reason for building a game engine. Next, this was one of my driving reasons was to build a portfolio piece. I had a lot of back-end stuff, but it wasn't particularly visual. And what I found is that back-end, when you've got a recruiter and you're trying to show them, some cool thing that you built, but it's all databases and sort of networking stuff, it's quite difficult for a recruiter to visualize this, under the hood kind of thing. So, but a game engine is excellent because not only does it have a very strong front-end element to it, they can interact with it, they can yeah, there we go. They can interact and see some kind of cool effect on their screens. When a technical person opens it up, they can also see something which is absolutely incredible. Whereas a lot of like back-end stuff you wouldn't quite get like the hit of like, wow, it's really visual and it's really technical at the same time. So a portfolio piece is a great way to bridge front and back, technical, non-technical. In red, because you want to build a good game, this is a thing that I can say for sure myself and seems to be a bit of a consensus among the industry, that if you think that you're going to build a game engine to build a good game, you're probably not. A game engine in itself is such an extremely resource-heavy thing to build in time, in concentration, and just the sheer skills that you need to build a game engine. The chances that you're going to still have enthusiasm and resources left over to build a game is like almost zero. So like if you're thinking, I'll build a great game engine and then this killer game, I would probably give you the spoiler alert. Probably don't do that. It's not such a good idea. But then, that being said, if your game has unique requirements, so Unreal Engine 5, the visualization in that game, the graphics rendering, the level of detail in UE5 is absolutely off the charts. They've got something called Nanite, which is for level of detail, and it's absolutely gorgeous. And then there's the Unity engine, which is really good at handling a tremendous number of moving components. But neither Unity or Unreal Engine 5 can do both of those things at the same time really, really well. So the Swarm engine, which was made by Saber Interactive for World War Z, and then they polished it up for Space Marine 2. It's phenomenally gorgeous to look at a hive city, which is multiple kilometers tall, and the level of detail going off into the distance at the same time as thousands of agents swarming across the battlefield, and you can interact with them, throw grenades and shoot them and stuff. And so the Swarm engine is an example of your game has some kind of thing that you want it to do, but there's no pre-made engine to do it. And again, back to the previous one, it's very expensive. So that would tend to be something where there's like a really well-funded studio who want to do that. But that would be an excellent reason for sure. So let's jump on to the general architecture. So I want to look at input just very briefly, even though the rendering and the simulation are really more important. But the input highlights something which comes up quite a lot, which is that sometimes there are bits of the game which run persistently, like rendering and the simulation. And sometimes there are parts of the game engine which run on events. So you click on something and something happens over a short duration. And input is one of those weird things that can do a bit of both. Sometimes you want it, well, you do always want it reading inputs in the background, but you don't always want it to act on the event of a click. Or if it does act on an event, you don't want it to keep acting on the event. It's a weird one because it's both persistent and event-driven. So input is a weird one. That's why I want to mention it. And input would also be a bit like audio and some graphics events that take place both simultaneously or persistently, but also sometimes event-driven. However, rendering and simulation, they take place all the time. So I think the easiest way to describe the rendering and the simulation is a flip book. So unfortunately, I should have put a thing in the middle and should have said game state, but I forgot. So the game state would really be the whole grid that you've got in here. And the simulation would be like the logic that happens at updating each of the cells. So in this case, it's a little Mario guy walking across grass, and you can see like the way his feet are moving. That would be the simulation that decides which parts of your data structure are updating and what kind of rules have they got to do those updates. And then the rendering is effectively like you looking at it yourself with your eyes and then flicking through it with your fingers. That would be like the camera and then the FPS, which clicks at a certain kind of rate. And the reason why I like to split up rendering and simulation is because each of them is so distinct in their own way, and each of them has their own really severe bottleneck when you're programming something up. Well, I won't go into what because it's just a rabbit hole of things that can go wrong with both of these, but separating out the simulation. So you've got the entire game state running and being updated, maybe every frame, or there's weird optimizations where you can update bits per frame. And then the rendering won't necessarily cover all of the game state, but the two of them are very closely connected. I've probably not described it very well. I should also have said that there's a GitHub for this. this project that I'm going to show you in a little bit. And you can go in and you can see the way that I've split them up. They're separate, and they just meet at one single data structure, which I think I've called game state buffer A and game state buffer B. So they meet. But the two of these run simultaneously. But this contains absolutely everything that is the game state and is updated every single frame, whereas this carries what is being shown on the camera and only updates the part of the game state which is visual inside what the player is seeing. OK, we'll move on. Am I getting in the way of something?
Just because the camera's only seen the back.
Oh, OK, all right. Well, yeah, that's no good. OK, so this is where this might not work very well because, yeah, actually, could I borrow you real quick? All right. So I wanted to give you a very brief demonstration of what you could do to start a game engine. We'll plug you in over here. So let's see. Yeah, there you go. So it's WASD like before. Sorry, I'm catching you out. If you turn and face the screen, that'll be you backwards.
Do you want me to stand this side?
I'm going to stand over there.
Cozy.
There will do.
Oh, I don't need to be in the shot.
No.
You look pretty, and I'll stand.
Yeah. OK. Yeah, that'll do. Right. So yeah, what you can see here, if you just give that little playthrough. So what you can see here is there's just a bunch of rectangles. And you can move forward, and you can move backward. And as you're moving through, you'll see that the rectangle, when the rectangle hits this breakpoint over here, the world moves that way. And if the rectangle goes to this side, it hits a breakpoint, and the world goes this way. And if you go between these two breakpoints, move back and forth, you'll see it's the character that is moving and not the world. And this is an interesting thing about game engines, is that you can build something which is very general, like Godot or Unreal Engine or whatever, that you can build all kinds of games with. Or if you want to start with something really simplistic, you just pick a game type. In this case, it's a platformer. And because you picked one specific type of game, your whole mechanics can revolve around, oh, go this way. Your whole game engine can revolve around just this one little piece of mechanics. And so now I'll show you what happens if you take that and you start polishing that. Oh, I just shut something down. Oops. If you take that and, oops. So this is the first game that I built. And this is the one I built to show that I could write JavaScript. You ready?
I'm ready.
OK, so get to the chopper. So you can see you've got this back and forth movement, which is just the same as before. Hit Y. Oh, yeah, by the way, this game is stupidly difficult to play. I built it without testing, which is an interesting thing that if you build game engines, get non-gamers who haven't played your game to test it, and they'll show you just like how difficult it is to play. So yeah, you can see that the concept is really similar. Platforms moving back and forward, but you can see all the extra stuff that's in here. There's backgrounds, there's parallax scrolling, there's physics to hit platforms. And yeah, it's stupidly difficult. So sorry about that. OK. Yeah, show them a gun, show them a pistol. That was space. Yeah, show them a grenade. Space bar. Yeah, there's a grenade. Yeah, the grenade was a pain. I had to build that at least twice. Yeah, there's a stab if you jump up and then press down.
A stab?
Yeah, jump and press down. Yeah, there you go. There's a stab. And you can see the sunset is going down behind. There's an interesting thing that when you're building a game, there are some things that you have an idea that turn out to be really difficult to actually implement. And then there are other ideas that add a lot to the game experience but are actually quite easy to implement. And in this case, the background, if you just let the background go all the way to the ground, the background is getting to sunset.
Oh, yeah.
And when it hits nighttime, yeah, got caught out after sundown and was consumed by the jungle. So it's actually a timer. And it's a way of visualizing this mechanic in the game that was so easy to put into the game, but actually adds quite a lot. So it's a nice little trick if you're building a game, you're looking for ideas. Look for things which are easy to implement, but have a high impact in the game. We're going to jump on. So yeah, I'm not really going into a whole lot of detail in this talk, but there is something I would like to get into the detail about, because if I'm going to share with you guys some things that I learned through my experience of game engine design, this is definitely one of them. So we're going to skip over this at quite a high level, but I presume quite a lot of you understand what object-oriented programming is. You've got a class, you've got functions, you have an array of classes or an array of objects, and then you can loop through them. In this case, we're applying breaks. So this is classical object-oriented programming. Well, one of the most interesting things that I learned in my journey in game engines is data-oriented design. And what this is phenomenal at doing, unfortunately, this is really bad, so there's a copy of this on GitHub that you can go and actually see the code if you're interested. But what this does is it does pretty much exactly what this does, but it does it with an efficiency that is just off the charts. Like this type of updating would typically be used in graphics rendering or image processing or anything that has a tremendous amount of data that you're trying to ram through with extreme speed. You would use data-oriented. And it works out really well in something like an RTS game where you have hundreds of agents moving around, or if you've got, I don't know, anything where there's a tremendous amount of stuff moving and they need to change their state very rapidly. So let me see if I can change. Let's try this. Oh yeah, OK. So here's a bit more of a broken down view in memory of what data-oriented looks like versus, or I should say, and object-oriented. So this is an object in memory, and this is a bit-by-bit description of what it looks like. And this is 24 bits, or no, it's 24 bytes, sorry. And you can see that the size of the car object was 23 bytes and 1 bit. The useful size that you're actually using for the calculation of applying brakes is 10 bytes and a bit. But the entire amount used is the full size of the object, which is 23 bits and 1 byte, meaning 13 wasted bytes. Now, if you look at the data-oriented design, you can see that the size ultimately is the same because every entity is still carrying the same amount of information. But when you perform the calculation, you're only using 10 bytes, and that's the exact amount that is useful. And so therefore, the amount of waste is absolute 0. And another thing about this is with the way that you're going through memory, you can see the arrows represent data that is used. And so the object starts here, but the useful stuff starts here, meaning that you'd have to do all of these jumps before you get to something useful. And then at the end, there'd be a whole bunch of jumps before you get to the end of this memory line. These jumps aren't free. So with these gaps in here, you're actually wasting quite a lot of processing time to skip over all of the useless information for this calculation, as opposed to data-oriented design, where in fact every single piece of information in the memory is a useful piece of information. And if it's not useful, it's just not in memory for this process that you're running. And the other thing is that if you would take this and put it in down here, you could fit 2 entities in the same space as you could fit 1 object. And so for this, and plus there's no jumping involved in the data-oriented design. So altogether, this is so much faster at processing a huge number of agents in a game, or it could be particles. I'll show you a particle simulator in a minute. Yeah, so here actually is the, here are 2 examples of where this would be useful. Are we falling off? All right. We good? All right, cheers. Here is, so here's the second game engine I built last year with, I started out myself and then brought on a team and we built this together. Unfortunately, we didn't manage to finish the game, but this is what you could use data-oriented design for. This is my YouTube channel. This is supposed to jump through. I like Warhammer 40K, by the way, in case you didn't realize. Yeah, of course, yeah. It's easy to detect. All right. Yeah. So that's 400 agents. And unfortunately, we were using object-oriented, not data-oriented design. But even at object-oriented, I was able to run 400 agents on my laptop, which is really a low-power laptop. I would love to know what we could have done if we'd have used data-oriented design. So there was that one, which was object-oriented. But that is an example of where you would use data-oriented. And then here's something that I did do. Actually, No, we should have set that up. Never mind. OK, so here is something I finished off last week. And this is purely for the purpose of seeing if I could, how many particles I could produce using data-oriented design. So this is JavaScript running on a not particularly great laptop, on a huge screen, in a browser. Actually, this runs better on my computer, but I can actually see that, that's 5,000 agents with 50 FPS, or 5,000 particles. And it just keeps going, keeps going. On my laptop, I can get to 9,000 particles before it drops below 60 FPS. And this is data-oriented design. So it shows you the difference in the power. There's a huge number of moving particles in this using data-oriented versus using a tiny number of moving agents using object-oriented. So that was my mistake last year, but I've corrected it here. In normal circumstances, running this on my laptop, I can get to 15,000 particles before it drops to 30 FPS. And it's not because it's a good laptop, it's a bad laptop, it's because it's data-oriented design. And actually, it's the rendering is the bottleneck why it's not running even more quickly. It could run quicker, but it's the rendering is slowing it down. OK, so let's jump on to. Yeah, so what comes next? I just realized I'm probably blasting through this way too quickly, but what comes next is, oops, you're not seeing that. There we go. Yeah, so what comes next is wave function collapse. Unfortunately, the guy who invented wave function collapse, it's not Oscar Stalberg, but the guy who invented it didn't realize that there's such a thing as wave function collapse in quantum physics, and so he also named it this. But in computing science, it's quite similar to a Sudoku solver, and it's a way that you can auto-generate terrain. And it's the idea, if you've ever seen Townscaper by Otto Stahlberg, it's not really a game, but it is fun. So I'm not quite sure what you call it, but something. And it's what it runs on, wave function collapse. So it's a way to generate interesting terrain with a sensible connection from one section to the next section, but it's not just like, it's kind of random. It changes it up a bit, and it's quite attractive. And then after wave function collapse, I'm kind of interested in this idea that I've been kicking around for a little while, which is a gamified neural interface. So when you're on ChatGPT, the interface that you have is a language-based interface. Once you get below the interface, what's going on is not really human. It's a transformer, which is a bit like a point cloud of data or something. Well, who knows, but that's a different talk. But so the interface is a large language model, but it doesn't have to be. What you could interface with a piece of AI could be just anything that provides any kind of input. And so I have this interesting idea that, like, let's say that you're going to play, this is Age of Empires 2. I think possibly one of the guys from Age of Empires 2 might be watching, so hi, Dave, if you're watching. So you could play Age of Empires 2 by typing in villager number 1, come to the edge of the farm, build a building, and then go back to the farm, collect the food and deposit the food. And you could type all this in language. But how you play it in reality in the game is that you'll use the mouse cursor, you'll select an agent, you'll give them a piece of instructions, you'll tell them where to carry out the instructions, and then you let them get on with it, and you go do something else. But what you could do is you could change the interface so that rather than this being a decision tree, which I'm pretty sure is what they are, correct me if I'm wrong, Dave, is that instead of a decision tree, it could be a proper AI that's running under the hood. And so rather than it just carrying out a pre-programmed set of decisions, if X, do Y, instead it could be a neural net. So it's able to assess, like, here's the input I'm given, but here's my thing that I want to do, that I've been trained to do, and then I'll go off and do these decisions. And so you'd end up with something that would look a lot like an RTS game or a little villager game or something like this, but the decisions that would be running under the hood would be far more randomized rather than just this pre-programmed path that you're taking. So yeah, I've got some ideas about how to do that. It's pretty experimental. I might not do it, but it's a thing that, this is the great thing about building your own game engine is if you want to do it, you do it. If you don't want to do it, you don't do it. It's just as where your interests want to go, that's where you go. So yeah, possibly that, or possibly a job. I'm looking for a job, so if anyone wants to hire me, I'm here. So yeah, okay, so there's that. Thank you very much. So all of this PDF and everything that I've spoken about here, the code examples, the links to all of the projects that you've seen in here, they're all through this GitHub over here. and also the actual little engine, the Mr. Blue Sky with the little green rectangles and moving around. If you're thinking of maybe you want to build an engine, I recommend that you have a look at it, and in conjunction with this PDF, because it will let you actually build something from scratch. Like it's just a tiny little kickstart, and from there, you just polish, add in some physics, add in some hit detection, add in a bunch of stuff, and it's a pretty easy entry point. There's really only a tiny number of files, and in conjunction with this talk, it should be a good point to get started from. So yeah, there we go.
Any questions for Samuel? Feel free, even if it's, can I get a shot of your game?
So are the places that you host your games on, or like kind of platforms and stuff like that? I mean, do you use it personally? Do you host it on your personal website?
I've so far not actually finished a game because I build engines. And so the engines are all available on my GitHub. And in fact, the Mr. Blue Sky, the little rectangle thing with the green and all that, that's through a GitHub page. So it's still in a GitHub repo, but it's on a GitHub page, and so you can interact with it through the browser. As far as launching games, I'm still not quite there yet. You know, just finishing an engine up to the point where you could produce a really good game I'm still not there. I'm still learning. So, yeah. Yes.
That made me think
Very quickly, sorry. For the live stream, if you could speak into the mic. I should have mentioned that. It's my first time hosting.
Yeah, that just made me think of another question, which was, would you ever consider opening up your engines to perhaps specific people that you've selected to get them to make a game, to prove the concept, to maybe work out the bugs, like getting QA done on, you know, a piece of code you've built. But no, the question I was going to ask was actually, I'm really interested in the wave function collapse, and will you either explain that quickly now or in longer later? Because I find that really interesting.
Yeah,
I'd
sure.
love to know more.
I'll explain it right now. So the wave function collapse, so you know how to play Sudoku? Okay, so in Sudoku, you kind of like, when you begin, you just like pick a random square, and from that square, you first pick possible neighboring squares that might have the solution. And you maybe just go into the piece of a pencil, and you just cross out all the ones that definitely couldn't be there. Like if you've got a 5 on the edge here, then you know that it won't be a 5 there or something. I don't really play Sudoku, but it's that concept. And so you look at the neighboring cells, and you remove the ones that it definitely cannot be, and then you pick one of the ones that it could be randomly, and then you move on to the next cell, and you do that again. And by the time you've gone through the whole thing, you maybe do 2 passes of picking out the ones that it definitely cannot be, and it reduces the number of potential next cells that you could have. Actually, I'll go back a little bit.
So is it a sort of a simplified loss function type of a thing, a bit like a neural net, but much, much like smaller in scale, or?
It's not like a neural net at all. It's like a grid where you go and you neighbor check. So
okay.
actually, if we go, oh well, I just was looking for a picture of a grid. So in Oscar Stallberg's, if you imagine that every cube in here is a cell, when you come to add a new section on top of a cell, it will look at its neighbor cells where there's something there. And then it will run through a set of all the things that it could potentially be. So maybe there was 100 different types of other things that could go here. It will look at all of them, and it will check, what are my neighbors doing? So in this case, it would be the cell below it, because there's just air on other sides. It would see, oh, I've got a roof below me. That means I can do something with a floor, but I can't do something with a, I don't know, a roof or a bridge or whatever. And it removes all the things that it definitely cannot be in one single pass. Right. And then on the second pass, it goes, well, if it definitely couldn't be all of these things, what's left? And could it be any of these? And then it sort of randomly picks one of the ones that it could be and pops it in. Right. And then when you follow that through, you end up with something that's got you know, a sort of a sensibility, like coming from here to here, that is sensible, but it's also not, like, actually, it looks like they maybe deliberately programmed this in, but I was going to say it's random, but it's not strictly random. There is a kind of a set of constraints that are like, it's not just, oh yeah, it's a roof, so we'll put a fountain. There is a certain amount of constraints with a certain amount of random.
So I suppose the rules you're talking about at checking, you would add those and say stairs must only go up, never left, right, and it would produce something like that. Or,
exactly.
Yeah, okay, yeah. Got you.
This is where the idea of the Sudoku comes in, that when you've got those cells in Sudoku, if you've got, like, because you're going lines horizontally, so you know if you've got a 3 on this line, then if there's a 3 and another one, then one of those 3s has got to be wrong. And so you've got a set of constraints based on what neighbors are doing. So you cross out all of the ones that definitely couldn't be on a first pass of neighbors. And then you come in a second pass and you say, what's left? Could any of these, do they definitely work? Or we'll just pick one randomly.
Cool, thank you, man. I think I totally get that now, and I think I agree with you. The name is an unfortunate one because it doesn't really help, given what you're. It's really confusing.
Yeah, it's a physics thing, quantum physics. I know nothing about. But any other questions? No. Okay, no worries. Oh, you, gentleman Ed, you had a question. Did I answer it already?
A lot of game engines get a community sort of form around them. Have you found interest in your engine?
I was actually shocked that when we built, I got rid of it. When we built the Great War engine last year, it started out as just myself, and I built this kind of little isometric map thing that you could like move the map around, and I was like, oh, this is really good. I wonder if anyone else would like to join me on it. And I put out what was basically a job description on LinkedIn, and just like I was really clear there was no money involved, but I didn't know quite how else to find anybody. And so I put out a message on LinkedIn being like, does anyone want to join me? Here's what I've got. Here's a video of it. And I was absolutely swamped with people who wanted to join up. And I had to do a lot of interviews because there were some people like, oh, that's really great. I want to make a game engine or make a game, and they'd never programmed before. And I found that for a community at that level, the enthusiasm was at its maximum, and the skill level was really not quite up to that same level. So we did like 2 more drives later on points because we ended up going up to a team of 8 at one point. And what I found was that the kind of like the perfect mix is someone who has a little bit of skill, a huge amount of dedication. And I got 1 or 2 people on the team who were absolute golden. There was this one guy who was not a good programmer at all, and he wrote this one function for putting trees into the world, and we used it from the day he made it until the day the project ended. And he wasn't an especially great programmer, but he just smashed away at that function to make sure it worked, and it really worked. So yeah, we did create a community, but maybe not a community like you were thinking, where it's like a community of users, but a community of people who are like, oh, this is really cool, I'm fired up, how can I get involved? And I got burned as well. Actually, the most experienced person on the team, I won't go into what, but yeah, he burned us. So it wasn't epic, there was no money involved. But so community, yes, the good and the bad. Any other questions? No? Okay. All right. Well, thank you very much, and hope you liked it. The GitHub's available. All right. Cheers.
Fantastic. Cool. Okay. Well, thank you very much, Samuel. I think that was so cool. I've never considered building a game engine before. Never mind a game, but it's inspiring. Okay, cool. Well, thank you all for coming, first of all. I've got a couple of things, hence the awkward laptop holding. So the next GlasgowJS will be on Tuesday, 10th of June, and it's going to be in this office again, so make sure to come here. At 6:30 p.m., so same time, same location, and the event theme is Let's Talk About AI. So it's going to be almost like lightning round, like 5 minutes per person, talking about various different ways that they use AI or various different things that they find interesting or exciting about AI. And Jamie asked me to say that if there is anyone else who thinks that they have something they want to contribute, let them know. If they still have space, I'm sure they'll try and squeeze you into the 5-minute lightning rounds. I think that'd be quite cool. So yeah, I'm looking forward to that one, definitely. Any future events as well, if maybe you're similar to Samuel or something completely different and you just want to share. I've done a talk at GlasgowJS before. I definitely had that imposter syndrome. I definitely didn't think I could do a talk, but I've done it. I know there's a few other people who have done talks before. Samuel has now just done a talk, and maybe a few other here or online as well. So yeah, feel free to just reach out to Jamie on Discord, or I don't know, however else you might find Jamie. Speaking of which, the Discord is great. It's a really cool place. If anyone's not on the Discord, I recommend joining it. QR code here. It'll also probably take you to the email list, I'd imagine. Excellent. I think I'm nailing this. The email list is also really good. You're sending out like weekly almost bulletins. Yeah, it's a good grind. I've learned a lot of cool things about what's happening in Glasgow just by checking out the email list, so that's really good. Thank you once again to BJSS, again, my employer, for sponsoring this, letting us use the venue, the pizzas, the drinks, So thank you very much. And as I mentioned, we're going to the Society Room. So that's the Weatherspoons, pretty close. I'll be there. I know there's usually like a group of like 10 people, but I mean, the more the merrier, absolutely. Thanks for coming. Cool. Awesome. Thank you.